Alright, so we know that I1 is 5 amps and I2 is 8 amps. And we need to find the magnetic force that wire 2 feels as a result of I1. Well, according to the right-hand rule, the magnetic field of I1 curls around I1 like this. So the magnetic field B1 points down like that. Now, the right-hand rule tells us that the magnetic force felt by wire I2 is Li2 cross B1. If we use the palm, thumb, finger rule, well, if I point my fingers in the direction of the magnetic field and I point my thumb in the direction of the current, then that tells me that the magnetic force points off in that direction, in the positive X direction. These two wires are going to repel each other. Okay, so we want to find the, I guess we need to find the force per unit length, right? So the magnetic force per unit length is going to be I2 multiplied by B1 times sine 90, because these are perpendicular to one another. Now B1, the magnetic field of wire 1 in the vicinity of I2 is naught I1 over 2 pi r. So B1 is 4 pi times 10 to the minus 7 times 5 divided by 2 pi over 0.24. Okay, that's, let's see. That's 4.17 microtesla. And so the force divided by the length is going to be 4.17 microtesla multiplied by I2, which is 8. So that works out to be 33 micronewtons in the plus X direction, with 3.3 times 10 to the minus 5, if you would rather. Okay, now part B. Right, that was part A. Part B asks, so if we assume that I1 is at a coordinate x equals 0, at what location is the total magnetic field equal to 0? Well, if you look on the left-hand side of I1, the magnetic field points up. On the right-hand side, it points down. Let's look over here at I2. For I2, over here, the magnetic field points up, and over on this side, it points down. So in this region in between I1 and I2, that cannot be correct, because there's no way that I1 and I2 can cancel. So it either has to be over here or it has to be over here. I'm going to pick this region over here because we want to be closer to I1, right? If we set the magnetic field magnitudes equal to one another, right? If I do B1 is equal to B2, let's take a look. We have u naught I1 over 2 pi x, right, where this is our distance x, and mu naught I2 over 2 pi times x plus 0.24, right, which is this distance. Well, over on this, well, if you consider over here on the right-hand side, if we had chosen this, then I2 is always bigger, and this quantity x, well, actually I wouldn't be using x plus 0.24 here, right? I would be using x minus 0.24. My point is that over here on this side, the I2 is always bigger, and the distance, R2, the distance to I2 is always greater than R1. And so, or always smaller than R1, I'm sorry. And so everywhere over on this side, the numerator is bigger and the denominator is smaller, which makes this whole thing bigger all the time. Over here on the left-hand side, it's possible, see, I1 is smaller, but x is also smaller. So it's possible to find a balance here where the term on the left is going to equal the term on the right. Alright, so let me simplify this. I have 5.0 over x is equal to 8.0 over x plus 0.24. So let's see, so this is 5x plus 1.2 is equal to 8x. So 1.2 is equal to 3x, and then x is equal to 0.40. Now it asks what x coordinate is the total magnetic field equal to 0. Well, we've gone over here to the left, and this is x equals 0. So the x coordinate is minus 0.40, right? The distance is 0.40, but the coordinate is minus 0.40. It's a subtle distinction, but it's important if you want to be precise.